Pleasant morning to one and all. I am Dr. Sumitra, an associate professor from the Department of Computer Science and Engineering. Today, we are going to discuss all about the process scheduling in operating system. The main objective of the process scheduling in an operating system is a mechanism by which an operating system decides which process or a task gets to use your CPU at any given time. Since a single CPU can execute only one processor at a time, the OAS uses a scheduling algorithm to manage a multiple processor effectively, efficiently, and fairly, ensuring that all processors get their turn while optimizing the system performance. The key concept in process scheduling is where you have a process states scheduler in operating system. The processor states is where a new ready running blocked and waiting terminated, where a new is a way the process is being created, and ready is a process is located into the memory and is waiting for the CPU time. Running is where the process is currently being executed on the CPU. Blocked waiting, the process is waiting for one event, and so on. The basic termination is where the process has finished execution. The scheduler in operating system is a long-term scheduler with a job scheduling determines which processor are admitted to the ready queue from the pool of process on disk, and this scheduler controls the degree of multiprocessing, multiprogramming. And we have a short-term scheduler where you have a CPU scheduler decides which processor from the ready queue gets to run on the CPU time, and the scheduler runs frequently and make a quick decision. And here is a process diagram in memory where we have a text data heap stack which a maximum limit from 0 to max. The process state, and this is a pictorial representation of a process state with a new, ready, running, waiting, and intermediate. The process control block is where you have a multiple states of process state with the process number, program counter, register, memory limits, and the list of open files. The information associated with each processor also having a task control block, process state running, your waiting, and the program counter, location of instructions to next executes, and CPU register. Content of all processor centric register, and you have a CPU scheduling information with the priorities of scheduling queue monitoring, and you have a memory management information where the memory is allotted to a processor, and we have an accounting informations where CPU is used to clock your time elapsed for a starting and the ending date. CPU is switched from one process to another with the process, operating system, and your processor. We have a threads too, where the threads have a thread is where you have a single thread of execution will be carried out with a multiple program counter per processor, and we have a multiple locations can execute at once in a time. We have a storage for a threads data and a multiple program counter in PCB, and so on. The program process representation in Linux is where you have the basic structure of a Linux environment with a basic T structure with a code specified given. And the process scheduling, as I told you, we have a multiple process scheduling on to maximize your CPU usage and quickly switch from one process of CPU to for a time sharing, where the process scheduler selects among the available processor for the next executions on CPU, maintains your scheduling queues of one process with the job queues, ready queues, and device queues. First come and first serve, where you have the basic description. This is the simplest scheduling algorithm, and the processor are executed in the term that derives in the ready queue. Easy to implement, and it can also lead to convince your text where the short processor or content waiting for a long process running in a poor performance. And you have a shortest job queues with the basic descriptions all about the algorithm selects your process with the smallest execution time to execute you next. And pros, it maximize your average timing limit, and which is efficient for your shared jobs. Here is a queuing. Here is your queuing process, queuing scheduling, and so on. I hope you're clear with this concept. Thank you.